Inside the Tesla Cybertruck factory, how the stainless steel electric truck is made. The first thing that feels strange inside the Cybertruck factory is that nothing looks like a traditional car plant anymore. There is no sense of curved body panels being gently shaped into smooth luxury lines. Instead, everything feels sharper, louder in a visual way, almost like the building itself is designed around geometry rather than design. Massive stainless steel sheets arrive like industrial mirrors, reflecting light across the production floor in a way that makes the entire space feel more like a spacecraft assembly zone than an automotive factory. And then you realize what is actually being built here. A vehicle that refused to follow decades of automotive design language and instead forced the entire manufacturing process to change around it. The Cybertruck begins its life in a material environment that already sets it apart from every other pickup truck in the world. Instead of painted steel or aluminum body panels, Tesla uses ultra-hard stainless steel that does not behave like normal automotive material. It does not bend easily, it does not flow into curves like traditional car bodies, and it does not forgive mistakes in manufacturing. That single decision changes everything. Because once you choose stainless steel of this grade, the entire production philosophy shifts away from shaping and toward precision folding, alignment, and structural engineering. Even small errors in panel alignment become extremely visible because there is no paint layer to hide imperfections. What you see is exactly what you get. Inside the stamping and forming area, giant machines press flat stainless sheets into angular body sections that look almost intentionally unreal. Instead of smooth aerodynamic curves, the Cybertruck is built from geometric planes and sharp transitions. It almost feels like someone took a concept sketch from a digital design program and forced it into physical reality without softening anything. Workers and robotic systems guide these heavy metal sheets through controlled forming stages where precision matters more than force. And unlike traditional automotive factories, where stamping is about shaping softness into elegance, here the challenge is controlling rigidity without causing stress fractures or surface distortion. One of the most fascinating parts of the factory is how differently stainless steel behaves during production. In normal car manufacturing, imperfections can be corrected later through paint correction or panel finishing. But with the Cybertruck, there is no cosmetic forgiveness layer. That means every cut, every fold, every weld, every alignment has to be nearly perfect at the structural level. Engineers constantly inspect edges and joints because even microscopic deviations can affect how panels meet each other across the angular body design. The entire truck is essentially a large stainless steel origami structure built at industrial scale. Then comes the structural frame assembly, which feels closer to aerospace engineering than automotive production. The Cybertruck's exoskeleton design means the body itself is the structure. There is no traditional separation between outer shell and internal frame. Everything is integrated into one rigid structure designed for strength, durability, and impact resistance. Large robotic arms position massive sections while welding systems fuse joints under extreme control. Sparks fly across angular surfaces while the truck slowly takes shape, looking less like a vehicle and more like a machine carved from industrial architecture. What surprises most people is how much precision robotics dominates this section of the factory. Tesla's manufacturing philosophy pushes automation heavily, and in the Cybertruck line that becomes even more visible. Automated systems move components, align panels, perform welds, and handle repetitive tasks with extreme consistency. But the complexity of stainless steel means human oversight still plays a major role. Engineers constantly inspect alignment because robotic precision alone is not enough when dealing with a design this unforgiving. The combination of automation and human correction creates a production rhythm that feels almost like controlled tension rather than smooth flow. And then there is the battery integration area, which completely changes the scale of the vehicle from a truck into a massive energy system. The Cybertruck is not just a pickup with a battery attached underneath. It is designed around structural battery integration, where the battery pack becomes part of the vehicle's structural integrity. This approach increases rigidity while optimizing space and weight distribution. But it also creates manufacturing challenges because the battery system must align perfectly with the stainless steel exoskeleton above it. Workers carefully position large battery modules while diagnostic systems check alignment, thermal pathways, and electrical connections. Every millimeter matters, because this system will eventually power acceleration, towing capability, and long-range performance under extreme loads. Inside the electronics installation section, the Cybertruck starts transforming from a raw structure into a digital machine. Wiring harnesses, control modules, sensors, cameras, and computing units are installed throughout the vehicle. And what is interesting here is how software-driven the entire system has become. The truck is not just assembled mechanically. It is essentially being programmed at the same time. Systems responsible for driving assistance, torque distribution, energy management, suspension behavior, and user interface all begin initialization during production. It feels less like building a truck and more like activating a platform that happens to have wheels. One of the most intense areas in the factory is the panel alignment and fitment zone. Because stainless steel reflects everything, even the smallest gap between panels becomes visually obvious. Tesla engineers spend a significant amount of time adjusting alignment of door edges, body seams, window frames, and external panels to ensure uniformity across the entire vehicle. Unlike painted cars, where minor imperfections can be hidden, the Cybertruck exposes everything. That forces a level of manufacturing discipline that is closer to architectural metalwork than traditional automotive finishing. The interior assembly section is where the harsh industrial exterior suddenly shifts into something surprisingly minimal and futuristic. Inside the Cybertruck, the design language is extremely simple compared to traditional vehicles. Large digital screens dominate the dashboard, clean surfaces replace complex buttons, and seating is arranged around functional space rather than decorative detail. Workers install seats, climate systems, storage compartments, and interior panels while keeping the focus on durability and usability. Even though the exterior looks like a futuristic armored machine, the interior is designed around everyday practicality, which creates an interesting contrast inside the same vehicle. Then comes one of the most important stages: final system calibration. At this point, the Cybertruck is no longer just a physical object. It becomes a network of interacting systems. Suspension calibration, steering response tuning, braking balance, motor synchronization, sensor alignment, and software verification all happen before the vehicle is cleared. Engineers run diagnostic sequences while the truck remains stationary, checking every subsystem for consistency. Because once it leaves the factory, most of its behavior will be controlled through software updates and real-world adaptation. And what makes the entire Cybertruck factory so different from traditional automotive manufacturing is the philosophy behind it. This is not a vehicle designed and then manufactured using existing methods. This is a manufacturing process rebuilt around a completely new vehicle concept. Stainless steel forced a change in production logic. Structural battery integration forced a change in assembly design. Software-driven systems forced a change in how the vehicle is finalized. Everything had to adapt at the same time. By the time the Cybertruck reaches the end of the line, it no longer feels like a conventional pickup truck. It feels like a physical experiment in how far automotive design can be pushed when material science, software engineering, and manufacturing automation all collide in one place. And watching it roll out of the factory is less about seeing a finished vehicle and more about seeing a new definition of what a truck is supposed to be. The final rollout of the Cybertruck inside the factory feels less like a typical vehicle leaving production, and more like something being released after a long, controlled experiment. It moves slowly at first, reflecting light off its stainless steel body in sharp, broken patterns that shift with every angle. There is no soft transition in its design, no visual warmth in the traditional automotive sense. Just pure geometry moving through space with a kind of silent confidence. And that silence is what stands out the most. Because for a vehicle that was once described as impossible to build at scale, seeing it move smoothly through a real production environment changes the entire perception of it. Before it ever reaches open roads, the Cybertruck goes through a final validation process that feels almost like a stress rehearsal for real life. Every system is pushed through controlled simulations where engineers test how the truck behaves under acceleration load, braking force, suspension compression, and electronic response. The stainless steel body is inspected under intense lighting angles to ensure panel consistency, because reflections will reveal any imperfection immediately once the vehicle is outside. Even the door mechanisms, which look simple from the outside, are checked repeatedly for alignment accuracy and long-term durability. In a design this rigid, small misalignments are not just cosmetic issues. They become structural tension points over time. What becomes increasingly clear inside the factory is how deeply software defines the Cybertruck's personality. Unlike older vehicles where behavior is locked into mechanical systems, this truck is constantly shaped by code. Acceleration mapping, torque distribution, traction control response, regenerative braking behavior, steering assistance, and energy efficiency systems are all governed digitally. During final calibration, engineers are not just testing hardware anymore, they are tuning behavior. It is a process where physics and software meet and have to agree on how the vehicle should feel in real conditions. That balance is what determines whether the Cybertruck feels aggressive, stable, efficient, or unpredictable once it is actually driven. The battery system integration is another moment where everything comes together at a structural level. Once fully assembled, the Cybertruck is not just carrying a battery pack. It is fundamentally built around it. The energy system defines weight distribution, rigidity, center of gravity, and even how the suspension reacts to movement. Inside the factory, diagnostic systems simulate load variations while engineers monitor thermal behavior and energy flow consistency. The goal is not just range or power output, it is stability under pressure, because this vehicle is expected to handle towing, off-road conditions, and long-distance travel, all while maintaining consistent performance behavior. One of the most interesting contrasts inside the factory is how rough and precise the same vehicle can feel during different stages of production. Early assembly looks industrial and heavy, almost chaotic in scale, with large metal components being moved, aligned, and locked into place. But as the Cybertruck gets closer to completion, the process becomes increasingly delicate. Engineers start focusing on micro-adjustments instead of large structural changes. Panel edges are refined, sensor alignments are corrected, software behavior is fine-tuned, and internal systems are tested repeatedly. It is almost like the vehicle shifts from being constructed to being calibrated. And despite its futuristic appearance, the Cybertruck still goes through traditional automotive validation processes that exist in every serious factory. Rain simulation chambers test sealing integrity. Suspension rigs simulate rough terrain conditions. Electronic systems are stress-tested for failure resistance. Even something as simple as door closing force is measured precisely because customer perception depends heavily on these small physical interactions. The difference is that in this factory, those traditional tests are layered on top of software validation that did not exist in older automotive eras. That combination creates a production process that feels like two generations of engineering happening at the same time. Inside the final inspection zone, the Cybertruck looks almost surreal under controlled lighting. The stainless steel body reflects the environment in fragmented patterns that make the vehicle appear slightly different depending on where you stand. Inspectors walk around slowly, checking alignment, surface consistency, and mechanical response while the vehicle remains completely still. There is something unusual about seeing a machine designed for extreme durability being treated with such precision at the end of production. It highlights the contradiction at the center of the entire project. A vehicle built to survive harsh conditions is also built with extreme manufacturing sensitivity. And then comes the final moment where the Cybertruck transitions from factory product to real-world machine. It rolls out of the facility with all systems active, all calibrations complete, and all diagnostic checks cleared. At that point, it is no longer just a collection of stainless steel panels, battery modules, motors, and software systems. It becomes something that will be interpreted differently depending on where it goes. For some, it will be seen as a breakthrough in automotive design. For others, it will feel controversial or unconventional. But inside the factory, none of those interpretations matter. What matters is that every system performs exactly as intended when it leaves controlled conditions and enters unpredictable reality. And as the last Cybertruck in this production sequence moves toward the exit, there is a strange feeling inside the factory that is hard to describe in technical terms. It is not celebration, and it is not completion either. It is more like a transition point where something extremely controlled finally hands itself over to something completely uncontrollable. The factory can guarantee alignment, calibration, torque values, software behavior, structural integrity, and quality consistency. But it cannot guarantee how the Cybertruck will be used, tested, modified in perception, or pushed once it reaches the outside world. And that is where the real identity of the vehicle begins. The final moments before delivery are filled with last-layer inspections that feel almost unnecessary at first glance, but become important when you understand the philosophy behind Tesla manufacturing. Every Cybertruck passes through repeated validation loops where cameras scan the stainless steel body from multiple angles, looking for reflection distortion that might indicate surface inconsistency. Sensors check that all electronic modules are communicating correctly. Suspension systems are cycled through different load states while the vehicle is stationary. Even the steering system is tested for micro-level response accuracy. Because in a vehicle this rigid and heavy, small inconsistencies can become amplified once it is on real terrain. What stands out most in these final checks is how deeply software and hardware are now fused together. The Cybertruck is not treated as a finished mechanical object waiting for a driver. It is treated as an active system that is already partially alive before it even leaves the factory. Engineers run full system simulations where the vehicle behaves as if it is already on the road, responding to virtual inputs, reacting to environmental changes, and adjusting internal parameters automatically. This blending of physical inspection and digital validation has become one of the defining traits of modern electric vehicle manufacturing. And the Cybertruck represents one of its most extreme examples. And then, there is the moment where all systems are considered stable enough to release the vehicle. It is not dramatic in the way people imagine. There are no speeches, no visual celebration, no sense of ceremony. Instead, the Cybertruck simply begins to move under its own power, slowly at first, almost cautiously, as if it is being introduced to a world that has been waiting for it for years. The stainless steel body reflects the factory lights one last time, breaking them into sharp geometric fragments before the truck rolls forward into daylight. And that reflection feels symbolic in a way, because nothing about this vehicle is smooth in the traditional sense. Everything is fragmented, angular, intentional, and deliberately different from what came before. Outside the factory gates, the environment changes instantly. The controlled silence of production is replaced by unpredictable sound, weather, terrain, and motion. This is where the Cybertruck leaves the world of controlled engineering and enters the world of real usage. Every design decision made inside the factory now faces conditions that cannot be fully simulated. Road imperfections, temperature variations, driver behavior differences, charging habits, load conditions, and long-term wear all begin to shape how the vehicle behaves over time. And this transformation is where the true test begins. What makes this transition so important is that the Cybertruck is not just another vehicle entering production. It represents a shift in how manufacturing itself is defined. Traditional automotive factories built vehicles around long-established expectations. Trucks had certain shapes, materials, and behaviors that evolved slowly over decades. But here, the entire concept has been reinterpreted. Stainless steel replaces painted panels. Structural battery integration replaces traditional chassis design. Software replaces fixed mechanical behavior. And automation replaces much of the repetitive human assembly process. The factory is no longer just assembling parts. It is assembling a new definition of what a truck can be. Inside Tesla's production environment, that philosophy is visible in every corner. The way panels are handled, the way structural components are aligned, the way software is installed alongside hardware, the way testing systems continuously loop through validation cycles. Everything is designed around iteration rather than finality. Even when a Cybertruck leaves the factory, it is not considered frozen in time. It is expected to evolve through software updates, performance adjustments, and real-world learning. In a sense, production does not end at delivery anymore. It continues throughout the life of the vehicle. And that idea is what makes watching Cybertruck manufacturing so different from traditional automotive storytelling. Because it is not just about how a vehicle is built. It is about how a vehicle continues to change after it is built. The factory is only the starting point of its identity. The real identity forms later, outside controlled environments, where unpredictability replaces calibration and real usage replaces simulation. So as the factory continues its endless cycle of producing the next unit, the next battery pack, the next stainless steel frame, and the next software-calibrated system, each Cybertruck that leaves carries the same quiet contradiction with it. It is one of the most precisely engineered vehicles ever produced, yet its true behavior can only be understood in an environment that is not precise at all. And that is the final reality of it. The factory builds certainty. The world tests it.